Hello everyone. Today we're in part 2 of the book, and we're starting with chapter 1, which is about the strategic form of a game. Now here there are going to be two players, like usually. We'll call them number 1 and number 2. And the games we'll discuss here are so-called zero-sum games. Now what does that really mean? Well, it just means that player 1 wins exactly the amount player 2 loses. So if player 1 wins $3, then player 2 is losing those $3. And this means the sum of the winnings is always 0. So that's the reason why we call it zero-sum games. The setup for is what I'm going to tell you now. Player 1, he has to choose a particular strategy, usually called lowercase x, in a big set of possible strategies. And player 2 has to do the same. He or she has to pick a strategy to play with. And now they do this independently, so they don't know what the other player is choosing. After they've picked a strategy to play with, there's a function that's often called a of x that tells us the amount paid to player number 1. This number can be negative, which just means that player number 1 is actually not receiving money, he's paying money. Let's see how this concept works for the game tic-tac-toe. So here's the tic-tac-toe board, and player number 1 is going to be the X, and player number 2 is going to be the O. And let's make player 1 start, and the strategy that he is going to use is he's always going to place an X in the lowest possible, leftmost possible free cell. So his first move is to place an X here. And let's imagine that player number 2 places his first O here. Now it's player's 1 turn, and he puts an X in the lowest possible, leftmost possible cell, which is there. Now player number 2 sees what's going on, so he's going to block here. Now player 1 has to move again. He has decided to always play with putting an X at the lowest possible leftmost cell, so he places an X there. And now player number 2 can win. So that was just an example of a possible strategy. It wasn't really a good strategy. A game called odd or even. And here there are only two possible strategies for both players. Player number 1 can choose the number 1 or 2. Player number 2 has the same choices. And after they pick a number, 1 or 2, we look at the sum. If this sum is even, then player number 1 wins the amount of the sum. If the sum is odd, player number 2 wins the amount of the sum. Now we'll show that if this game is played repeatedly and player number 1 plays in a smart way, then he can guarantee to win 8 1/3 of a cent each time the game is played, on average. When this happens, when a player can guarantee to win some fixed amount, this is called the value of the game. And this favors player number 1 because he's winning a positive amount on average. So this is not a fair game for the players. Now, this is a special case of the so-called which is due to von Neumann, one of the big names in game theory. It basically says that given any game where you have to pick strategies, and there's only a finite amount of strategies available, then there's always a value for the game, and there are good ways or good strategies for both players that give the players the value on average each time the game is played. Strategies to guarantee the value on average. And that's basically the gist of the whole chapter.